And I think you guys are going to want to watch this video, because I gotta say, it's not very often I pull one out of the box and I'm like, man, that looks really good. But so far I'm impressed just on looks. I've not tested it, not plugged it in, but just looking at some of the things that I've seen, very, very impressive. This sells for $358 on Amazon right now. But anyways, first things first, I just wanted to tell you that this thing, you know, is a beast. I mean, this thing is pretty heavy. I'll get you a weight here on it in just a minute, but this thing is heavy. So this is all aluminum, the sides, all the way around, except on the end caps. But you can see, I mean, this thing, it's a handful. I mean, I've tested several 3,000 watt inverters, and I don't think I've tested one that's been this beefy. I mean, the housing on this, it's very, very heavy duty. Very impressed with the casing. Usually the 3,000 watt inverters are not in a case this size. They're usually smaller and maybe 3 inches tall, where this one's a lot bigger. I'm gonna go ahead and get you guys some measurements, and I'm gonna measure from the end of these caps here to the end of this hardwire terminal right here. And so it's going to be about 15 1/8 of an inch long, and it's 8 inches wide, and it's 6 3/4 of an inch tall. And online on Amazon it says 15.5 pounds, and when I weigh it here, it's 16.4. And I've checked this scale and it's accurate. Here on the end, you've got a little LCD screen here at the top, and then you've got a push button here, a green and a red light. And then there is a remote jack right in there. And this inverter comes with about 30 foot of cable, or a wired remote. Also, it comes with a wireless remote. As you can see, you've got not one, but 2 USB ports right in there. They're just USB-A. And then here on the bottom, you've got 4 15 amp receptacles, and they're rated at 1,500 watts a piece. They said not to go over 1,500 watts. And then right in here, you've got your grounding lug, and a lot of companies don't do a very good job at putting nice grounding lugs on here. But this one here is very heavy duty, and you can see it's brass, and it's got a big brass nut on the end of it. And then you've got not one, but 2 grounding wires. You've got one here that's got 2 ring terminals on this end, and then you got another grounding wire that's got a ring terminal on one end, and then you've got just like a little alligator clip on the other. And then over here you've got your hardwire terminal. It's just hidden behind this plastic cap. So this AC terminal block right here is rated for 1,500 to 3,000 watts. So you can hardwire it in, and you can run your wire out the side right here. So moving on to the back side here, we've got this 4.5 inch fan. I mean, this thing is massive. You've got these big covers. These are really thick, heavy duty covers that goes over the terminals. But then here's something that's very impressive. Look at that brass stud. I mean, that thing is massive. So you can see right there, guys, it's a 10mm stud. I mean, that thing is hefty. You know, it's got a brass flat washer and a brass nut. Now, I would love to have seen them put a lock washer on there. So if it was me, I would probably add the lock washer. But to see a brass stud and nut and flat washer, you only see that on higher end inverters and things like that. I mean, but this thing is massive, and like I said, these covers that goes over them, very thick plastic. I gotta say, I mean, this thing is not what you're used to seeing on a Chinese inverter. This thing is built really, really well. So the reason that stud is so thick is because it's got to carry a lot of power. Like I said, it's 3,000 watts, but usually, most of the time, just for a 3,000 watt inverter, the stud's not usually that big, and it's not usually made out of brass, and there's usually not 2 wires. But this one here is very beefy, and they provided you with 2 power wires and 2 ground wires. And I know what you're going to think, and I know what you're going to think that I'm going to say is the wires are too small. Actually, they're 2 gauge wire. So They are rated at 1500 watts each. So, 15 and 15, that's 3000 watts. So, it's right at the bare minimum. We'll see if these things get hot. I don't know without testing them. Wires do look like they're of good quality. They've got a PVC jacket. They're really flexible. The term lugs right there are tinned, but they are copper lugs, and the heat shrink looks nice and tight on all of them, and it is copper wire. So all we can do is test it and see if it's able to handle the power of this 3000 watt inverter. Now, before I forget, I wanted to mention that VOLTWORKS gives you these little pads here, and I believe there is 8 of them in here. And what these are for, they're just little vibration pads. So you can slide them on the feet there. So when you screw them down, let's say you're in a motorhome or something like that with a lot of vibration, these just help with that and take some of that vibration and shaking out of the mounting system there. And they actually work really good. All right, guys, so I was really excited. I thought, man, for once, I'm going to find an inverter company that, is going to get everything right. And so I was bragging on these caps here, and they are great. I love them. But the wires that they sent, surprise, the wires that they sent, when you have to bunch 2 of them up together, you don't want to, pinch the wiring and get that heat shrink under there. You want it to be a flat metal to metal mounting surface. And so that's about as close together as you can, get them tightened. Without them, getting up on that area. Even if you took and cut some of that heat shrink away to mount them as close as they can fit, you can't get the terminal cover over top of them. So what this is made for is not for 2 separate wires. It's made for just one big wire. And so that's why in every one of the videos I recommend to you guys the new Concepts wire. This is the 1/0. And this stuff's rated for 375 amps. This stuff is awesome. And so I guess what I'll do whenever I decide to run this personally, I will just take and give it some 1/0 wire. And as you can see, it'll fit right out that cap right there. It's made for just 1 wire. It's not made for 2 like they've got here. So VOLTWORKS, if you're watching, make sure that you guys upgrade the wire. Put a 1/0 wire on here. Or larger. You can fit even larger there. So I would definitely upgrade the wire, because these 2 small ones, while they might be able to handle the load, you can't get the cap on there without cutting it and modifying it, and who wants to do that? So anyways, now that I'm off my soapbox, I do want to mention I'm going to go ahead and test it with these 2 wires on here. And it's kind of crazy, because to tighten this thing up, you're having to use a 17 millimeter wrench. These are brass terminals, so don't go stupid with it and tighten them down to 100 foot-pounds. You don't need that much. Just make sure that they're nice and snug. And then, also keep in mind that, like I said, you want to put a lock washer on here if you're mounting this permanently. I'm not mounting it permanently. I'm just doing it for the testing, so we're going to do without the lock washer. I'm going to go ahead and take this resistor here, and I'm going to touch it to the negative post on the battery terminal there. And as you can see, I've got these 2 connected on this furthest terminal, and I've got this negative connected to the furthest terminal on this side, and that way it's feeding off of both batteries equally. And so you can see right there was no spark or anything when I touched the 2 together. So that's why you use that resistor, so there's no spark. So I want to go ahead and tell you that I tested the remote. It takes an A23 battery, and the thing works great. And I'll put it aside, and then right here you've got this cable to hook up the wired remote. They give you a ton of cable. This thing is 30 foot long, and I'm just going to plug it in here, and it is pretty much just a old telephone style jack, and you can see that it plugs in here on the back. Depending on how you want to mount it, you need to account for that plugging in there on the back, but it just shows you like a battery level indicator. You've got a power and then a fault, and then you've got an on and off switch, so you can turn it on and off. And what you would use this for is, let's say you're in a motorhome and you've got the inverter mounted in a lower compartment, and you want to be able to turn it on and off at nighttime. Turn it off, and that way it saves the battery and keep from running it down. So that's pretty neat. All right, so I checked it with a clamp meter, and on standby power consumption, it's using just under 10 watts, which was pretty surprising for an inverter this size. The voltage here on the screen, it says 13.8. That is your battery voltage, and that is correct. And then right here, it says your output voltage is at 119, 120. Keeps fluctuating back and forth. And you can see I've got a watt meter plugged in here, and it says 119.8. That's pretty accurate right there. It's at 60 hertz, so that's right where you want to be. And so I'm fixing to probe this terminal here, and we're going to check the sine wave with the oscilloscope. And so you can see right there, nice clean sine wave. Alright guys, so I went ahead and turned on this space heater up here on the right hand side, and it surged all the way up to, let's see here, 1404 watts. And then right now it is running at 1268 watts, 69 watts. So you can see that it's kind of, you know, stabilized out. So I'm going to set this one to the side, and I've got another cable plugged in here, and I've got a watt meter going to it. And I had to put a splitter on this to go to this heater here. I've not turned it on yet. So right now it's only using 1.8 watts. I'm sure it's that LED. That's why it's only using 1.8 watts. But I'm going to turn it on high. So now it's on high, and you can see 300, 400, 700, 800, 900, 1,000. I see 12, 13, 15, 1596, 16, 1640 something. So yeah, this thing surged all the way up to 1640 something watts, and now it's stabilizing back out, and you can see them both together here. This one's at 1275, and this one over here is at 1462. So the math on that, when you add them together, that is 2,737 watts. So I need about 200 and something watts to get up to 3,000 watts. So I've got to plug something else in here. And so that's why I put a splitter right here, because I knew both of those fans wouldn't add up, or both of those heaters wouldn't add up to 3,000 watts. Even though they're 1,500 watt heaters, they just don't get up, and you know, they don't stabilize out at 1,500 watts. They don't, like I said, this one's at 1448, and this one here is at 1274. And it's crazy because this one here at 1274 is actually the bigger heater. So you would think it would you know, use more power, but for some reason it doesn't. And they're both, like I said, they're both set on high. Let me find something else to plug in here. All right, guys. So for the load test today on this inverter, we're going to go ahead and try to run it up to 3,000 watts. And so I've been testing it off camera. A while ago I had another space heater up here, and it wasn't putting out enough, using up enough watts. So I switched it out for this smaller heater. And it's funny because you would think a bigger, taller heater, it would, you know, probably, you know, maybe use a little bit more wattage because it does have a bigger heating element in it. But for some reason, it just doesn't, you know, get up that high. I don't know if something's the matter with it or whatever. But we're going to plug in this heater here, and we've turned it on high, and we're going to watch it here. It's at 1,560 watts, 1,592, 1,594, I think was the highest that I seen it surge to. And now it's going down. So I can tell you what it surged to by looking here on the watt meter. 1,594 was the highest. You can see right there. So let's go back and see what your real-time wattage is. It's 1407 right now, 1405. So we got about roughly 1,400 watts going right here on from this heater. So now keep in mind, each outlet here is rated at 1,500 watts each. Now if you need more power than that, then you can hardwire to this terminal here, and you can use 1,500 to 3,000 watts if you hardwire. So I'm not doing that. I'm just going to use the 1,500 watt terminals, and we're going to see just how much power we can get out of it. Now before I go ahead and turn that other heater on, I'm letting this one stabilize out, and it's at about 1400 watts. And this one here is only at 1.8 watts because just the LED light is turned on, but I'm going to kick it on. And 650, 900, 11, 12, 13, 14, 15. And it shut down. No surprise, guys. That was only 2,915 watts. So if you're wondering why did it shut down, I don't know. But I got a good idea that it was probably the damn wires. And, you know, I could be wrong. It might not have been the wires, but I would like to try and check it. So I have a couple wires made up from New Concepts, and they're 1/0 instead of, you know, they're 1/0 wires instead of the 2-gauge wires here, and using 2 of them. You know, I hate this. It's messy, and, you know, while it can supposedly handle that load, it didn't. So either it's the wires or it's the inverter. So we're gonna switch these wires out, and then we'll test it and make sure that it's, you know, that if it is the wires, we're going to call it the wires. If it's the inverter, we're going to call it the inverter. But one way or another, we're going to test it, and we're going to give an honest test on this inverter. So stay tuned. All right, guys. So like I said, we're going to pull these Chinese cables off, which we did, and we're going to replace them with these 1/0 New Concepts wire. And we're going to see if it's the wire or the inverter. But before I went ahead and hooked it up, I just wanted to show you guys that there is a huge difference between these wires that these Chinese inverters send and these New Concepts wires. I mean, look at that. And you might be saying, oh, well, they give you 2 of these red ones here. And they did, but you got to remember that's a lot of jacket on there compared to this one wire where it's just, I mean, this thing is solid. It's got, let's see, if you look right here on the jacket, it says Colossus Flex Cable by newconcepts.com. This is 1/0 power cable. It has 5,145 strands of oxygen-free copper. I made a video a few weeks ago that you guys might have seen where I cut these and showed you all the different strands that they have inside of them and how flexible they are. I mean, look at that. They got a PVC jacket on them, and the terminals that I'm using, these are copper terminals. These are from a company called CellTerm, and I buy these on Amazon. I'll put a link in the description for the New Concepts cable and the CellTerm lugs there. This is just what I use, so we're going to hook this up and we're going to see if it's the Chinese cables or if it is the inverter. And so you can see that they give us 2 grounds and 2 positive wires before, and we're just going to replace it with these 2 here and not have a bird's nest of wires. Alright guys, so I got the cable switched out, and I've not tested it yet, so I'm excited. So first things first, we're going to turn it on. You can see right there the battery voltage is at 13.3, the AC voltage is at 118, and it's going to 119. And then we're going to go ahead and plug this in, and we're going to turn this heater on. There it goes. Now it's at 800, 1041, 1487, 1509, 1550, 1585, 1588, 1589. So 1589 is what it looked like it surged to. I can check. 1594 was the highest that it surged to. And right now it's stabilized out to 1409, 1400. So we're going to leave this one here and leave it at 1400. And it'll probably go down just a little bit, but not much. And then next, we've got this space heater. We're going to plug it in to this other AC outlet. Keep in mind, you know, you can only plug in 1500 watts per outlet. So if you're going to go over that, you've got to go to this hardwired terminal here, and you can use it from 1500 watts to 3000 watts is what it recommends for. It's for high-powered devices. So we're going to go ahead and plug this in. And you can see right here, it's at 1.8 watts. That's probably just the display. And let's go ahead, before we turn it on, we're at 1397 watts. And we're going to turn this one on high. And we're going to see if it shuts off. If it shuts off, it has to be the inverter, because I've used these two batteries before and gotten over 3,000 watts, and I have used these wires before and gotten over 3,000 watts. So it has to be the inverter. Now, if it continues to run, then you know that it was the wires that VOLTWORKS sent with the inverter. So let's try it out. So you can see them side by side here. This one's at 630, 800, 900, 1000, 1100, 1200, 1300, 1400, 1521, 1540, and this one's at 1490. So guys, we're over 3,000. We're right there at 3,000. It surged. It was exactly 3,000. My girlfriend was running the calculator, and it surged up to 3,000 watts there. So now it's going to stabilize out a little bit, and that's fine. We're gonna try our best to get up there to 3,000 and show you that it can do the 3,000. So we're gonna find something else, because we're not quite to 3,000 yet. So we're gonna plug in a hair dryer. So stay tuned. All right, guys. So I've let it run for a few minutes, and you can see right here this finger, it says 1,430 watts, and this one's at 1,389 watts. And so what I'm gonna do is plug in this hair dryer, and I'm gonna try not to go over 1,500 watts per outlet like it says, but let's see if this will just put us just under. It might put us over. I'm not real sure, but let's see what it jumps up to. Yep, it must have been over on the amount of watts. Let me find something else to plug in it. But as you see, it reset itself, but these other two heaters are turned off. So we're gonna have to turn these back on and find something that's a little bit lower wattage. I wasn't going to turn it on the heat setting. I was just going to turn it on just the fan, and that puts out about 140 something watts, I believe, 140, 160 watts. We were going to see if we could get a little more than 3,000, but I guess we're not going to be able to, because you're only at 1,500 watts per outlet, and we're going to try to get up there as close as we can. So stay tuned, bear with us. Alright guys, so we have been testing the heck out of this thing on and off camera, and literally we've been running this thing for like an hour, and it shut off with just the wires that come with the inverter. And so we put these New Concepts wires on here, and these things don't even get, they're just lukewarm. And so it's not the wires, and it's definitely not the batteries, because I use these all the time, and so it has to be the inverter. And so we're going to give it one final test and see if we can get it up to the 3,000 watt mark. So right now we have this heater on high, and it's plugged in right here, and it's using let's just call it 1,400 watts on high. And then on this side we've got another space heater plugged in right here. I know the outlets are only rated for 1,500 watts, so that might be why it sorry to interrupt, but you heard the fan kick on just then. But that might be why we're having problems with it kicking off, because it says that each outlet's only rated for 1,500 watts, and these heaters surge above 1,500 watts, but only just for a few seconds, and then it comes down. So it should be able to handle over a 1,500 watt surge for just a split second. And so that's what we're going to do. We're going to test it, and again, right here, we're just call it 1,400 watts. So we're going to turn this one on, and it's on high, and we're at 600, 700, 12, 13, 14, 15, 1560, 1593, 1640, 1628. Now it's dropping down. 1560. So 1500. 1490. So there we go, guys. That got up to 3,043 watts, and that was surge. you know, that was surge on this one, and this was stabilized. So, but I'm just saying, it's still seeing 3,043 watts. But we're gonna wait for it to stabilize out a little bit and see what it gets down to, and then we might try to add a little bit more wattage to it to get back up to that 3,000 watts. Now, obviously, every time I've tried to plug something into here with a splitter and get closer to that 1,500 watts, then it shuts the inverter down. So I'm not even going to try to put a splitter on either one of these. I'm going to plug directly in to the inverter itself. And what I'm going to be plugging in there is just a box fan. And this on high gets about 75 to 77 watts. And so I'm going to go ahead and I'm going to plug it in. And you can see right here we're at 1427 and 1389 watts. And that is a grand total of, my girlfriend's working the calculator here, 2,816 watts. So if we plug this box fan in and we add, let's just say 75 more watts, that's going to put us at 2,891 watts. So if it shuts down when I plug the box fan in, then we'll know it's the inverter and it can't handle the 3,000 watts. So we'll see. Let me turn it on. Just turn it on high. You guys can see right there, 1426, 1385, and then 75 watts on the box fan. So far so good. So we're gonna let it run for a minute or two and see if it shuts down. But guys, that's as close as I can get to the 3,000 watt mark. So we'll just let it run for a minute. Right now it's at about 2,883 watts. So we'll just call it 2,900 watts. So we're 100 watts away from the 3,000. So seems to be running fine. Now, a minute ago, the fan kicked on, and it's on right now. If you want to come back with a camera and get a better look at it. You can see that is a big fan right there. That's about a 4.5 inch fan. And boy, does that thing put out some air. I mean, literally, it ain't no joke. I can feel that thing blowing right out the back and then sucking in here on the front. And it's really moving a lot of air. And as you guys see, it ain't having no problem. It's running the 2,900 watts. And I'm going to go ahead and turn the box fan off so you can actually hear the fan of the inverter, since we know that it's going to run the 2,900 watts. So the noise that you hear right now is from the fan from the inverter, plus I've got 2 heaters running in the room. But just to give you an idea, you know, it is running it. And you can see right there, you can see the fans moving. Alright guys, so I just wanted to prove to you there's a big difference in New Concepts wire and those cheap Chinese wires. Right now it's at 117 degrees right there on that terminal. But then if you come back over to the wire, I'm going to put it right there on my hand. It shows that it's about 112 degrees. 105. Let's see. 108 degrees right there at my finger. There it goes, 112. But keep in mind, that's 112 degrees compared to, you know, some of the wires that I've seen, you know, almost 100, I think 160, 70, 80 degrees the other week. I think one of them might have got to 190. But, I mean, this thing is running at its max capacity right at 3,000 watts. And it's just now, you know, it's at 112 degrees. So, that's pretty good, if you, in my opinion. You know, considering that the terminals back there, it shows the terminals are at about 118 degrees. That's the hottest temperature recorded on the screen right there at the bottom where my finger is. 118, you can see it right there. And then as far as the top of the inverter, let's see here. It shows about 105, 106 down here. We'll move it about middle ways. And it shows about 107. Let's move it up to the front. It's about 101, 102. Yeah, I've got two space heaters. One's 1420 watts, one's 1378 watts, 79 watts. And then I've got a box heater going on high, and that's another 75 to 77 watts. So roughly we're at 2900 watts. So I couldn't make it all the way up to the 3000 because I couldn't find anything that's, you know, close enough to that 100 watts without going over it and shutting it down. But I gotta say, I don't think it would have any problem getting to the 3000 watts. And so I gotta say, I'm very, very impressed with this inverter. The only thing that I'm not impressed with is the wires. The wires seem like that they were the limiting factor to being able to, you know, run the inverter and keep it nice and cool. You know, that's why I switched and put these new Concepts wires on here. And, you know, you can see I'm able to touch them and they're not ridiculously hot. You've seen in the testing that they remain cool, even though this inverter is right there at its max. And, you know, we haven't shut it down but for just a minute to plug and unplug stuff. So it's been running for over an hour. And so the inverter is still, you know, it is still 110 degrees right there in the middle. So, you know, I'm going to go ahead and turn some of these heaters off because it's super hot in here. But I just want to give you guys a listen to that fan right there. This thing moves a lot of air. So if you're looking for an inverter that, you know, is going to stay pretty cool from, you know, a lot of air movement, this one done really good for running at its max. Now, it is a lot more noisy than some of the other inverters, but you got to keep in mind this thing is moving a massive amount of air. Like literally I can feel it sucking in air through the front and shooting it out the back. But as far as it being a good inverter, I would say that, you know, it's seen 2900 watts. I think it would be able to do the 3000, and I don't see any problems with this inverter except the wires. And so like I said, I switched these the Chinese wires out that come with the inverter for the new Concepts wire, and you know, it's a drastic difference. And so gotta say, pretty impressed with VOLTWORKS. Again, they make a great inverter. And so if you're interested, check out my link in the description. And I gotta say, pretty impressed with the build quality on this thing. It's very nice. And so anyways, if you're interested in the watt meters or the resistors or the batteries, or, you know, any of the oscilloscope or any of the testing equipment that I've used, I put all that stuff down in the description. And there you go. You heard the fans cut off. And anyways, appreciate you guys watching. I know this was a long drawn out video. There was a lot of testing went on in this video. And guys, please like and subscribe and comment. You know, you guys at home don't realize that sometimes it takes 2-3 hours to test this stuff, and then, you know, then you got to edit the video and upload it and all this kind of stuff. And, you know, it takes a lot of time. And, you know, I don't get paid to do this. You know, I'm not making anything from YouTube. And, you know, if you buy an inverter from me, I'm just an Amazon affiliate, so I get very little commission from it. So, you know, I personally don't care if you buy it from me, because I don't, like I said, I make very little. But, you know, I one day would like to make a little bit of money from YouTube. So if you would, please like and subscribe to my channel. That'd help me out. And make sure you give me a thumbs up and comment, you know, and help keep me motivated, you know. So anyways, thanks for watching. Till next time, guys. See ya.